to the next exam, the sum and difference identities. I want to give them to you because you do have to understand how to work with them, but I don't want you to commit to memory them of where's the sine, where's the cosine, where's the positive and negatives, because they can be quite cumbersome. So let's just kind of work through on how to work with these. Example 1, evaluate a trig function. Find the exact value of sine of pi over 12. Now here's the deal. Pi over 12, if you were to go and type this in your calculator, it's going to give you a decimal. It's not going to give you an exact value. If you go to your unit circle, it is not even one that's on your unit circle. So what we want to do is we want to relate the angle we have to our unit circle to known values in order to find this exact value, not a round decimal. So first, let's consider how can we relate pi over 12 to things that we know? Well, that could be, if I were to take, say, 4 pi over 12 and subtract 3 pi over 12, those would be the same. Why did I choose these? Well, 4 pi over 12 is equal to pi over 3 on my unit circle. 3 pi over 12 is pi over 4 on my unit circle, and I have values for those. So if I come back to my trig function and say, looking at sine of pi over 12, and this is because I'm looking for exact values, that would be equal to sine of, let's use our reduced fractions, pi over 3 minus pi over 4. So I'm going to use my sum and difference identities. I'm using sine and subtraction, so I'm going to use this bottom one. So in the case of this problem, my alpha is going to be pi over 3. My beta is going to be pi over 4. So that gives us equal to sine of alpha, which is pi over 3, cosine of beta, which is pi over 4, minus cosine of alpha, which is pi over 3, times sine of beta, which is pi over 4. Now, we're going to go to our unit circles. Hopefully you have one handy if you don't have it committed to memory. And what would be sine of pi over 3? That's your square root of 3 over 2. What would be cosine of pi over 4? That is square root of 2 over 2. Minus cosine of pi over 3, which is 1/2. Sine of pi over 4, which is square root of 2 over 2. And so I've been able to relate this to known values, exact values, not decimals. I'm not even using my calculator for this. And then I'm going to simplify from here. So in the first one, if I am multiplying these together, that gives me square root of 6 over 2. Minus multiplying those together, square root of 2 over 2. And then putting those together, 2 times 2, these should be 4s. 2 times 2, this should be 4. So putting those together, they have the same denominator, so that would be square root of 6 minus square root of 2 over 4. And that would be my final answer. I do not need to run to a calculator because we're doing exact value here. Now, I know a lot of you, you've told me, you've showed me, you love degrees. So let's do one with degrees and show you how that's going to work as well. Find the exact value, you got to follow this process to get 75 degrees. So I consider 75 degrees and I break it apart to known degrees that I have. 30 degrees is on my unit circle and 45 degrees is on my unit circle. Now, since I'm doing the addition of cosine, I'm going to be using this function here. And I'm going to pick my first one to be alpha and my second one to be beta. So let's come down here and mark that. So this is going to be my alpha, this is going to be my beta. So this would be equal to, using that formula from above, that would be cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees times sine of 45 degrees. So using my unit circle, this gives me square root of 3 over 2 times square root of 2 over 2 minus sine of 30, which is 1/2. Sine of 45 is square root of 2 over 2. If you have not gotten a hang of using that unit circle, please reach out. Let me work with you and let's get you there. So putting these together, similarly, you multiply tops and bottoms. That gives you square root of 6 over 4. Minus multiply tops and bottoms. That gives you square root of 2 over 4. So it gives me square root of 6 minus square root of 2 all over 4. And again, I'm able to get an exact value using my known values on my unit circle. Let's do one more of these, and let's use it to prove something. So this says, proving a cofunction identity. Use a difference formula to prove the cofunction identity. So when you're trying to prove something like this, and you have two equal signs, but not equal to some value, what you want to do is you want to start with one side of it, such as this side, and then results in sine over x. And so that's what I'm going to do here. I'm going to start with cosine of pi over 2 minus x, and my goal is to end with sine x, and that would be proving this. So I'm going to use my difference formula. So that's my alpha and my beta, so this gives me, going back up to that formula, cosine of pi over 2, if I can write clearly on this, sorry about that, pi over 2 times cosine of x plus sine of pi over 2 times sine of x. So, knowing my unit circle, this is 0 and sine of pi over 2 is 1. So that cleans up to give me, well, cosine x, that's going to cancel. Let me just kind of write through this. 0 times cosine x plus 1 times sine x. And so this results in sine x. Now the online homework can be a little bit tricky because some of them have fill in the blanks for putting in all these pieces, but some will just say true or false. And so make sure that you walk through these steps, you understand this, because these are really good test questions, and these will be the steps that I would like to see. Let's take it another step further. We've used it with just plugging in to get exact values. We used it to prove. Let's use it in a situation. Example 3, it says to solve. And so on this one, I'm going to say, okay, let's figure out what we know here. I have sine plus cosine, cosine, and it looks to me like if I called this alpha and this beta, I also have an alpha and a beta. So I'm going to roll back up to these identities and let's look for that. So in these identities, you can see that sine of alpha, sine of beta, plus cosine of alpha, cosine of beta would be right here. You can see I've got 2 cosines alpha and beta and 2 sines alpha and beta, and they're being added. So this would be the simplification that I want to make down in this problem. And so instead of saying this whole piece, let's simplify that. So that would be equal to cosine of your alpha minus beta, so x minus 2x, is equal to square root of 3 over 2. X minus 2x, that's cosine of negative x, so square root of 3 over 2. And we know from that first box that we did, recall, cosine of negative x is equal to cosine of x, so I can make that substitution. And so where is cosine x equal to square root of 3 over 2? Draw your coordinate grid. That would be here when we have pi over 6, or that would be here when I have 11. Get my 11 right there. 11 pi over 6. So x would be equal to pi over 6 plus 2 pi k if it cycles around. And x would be equal to 11 pi over 6 plus 2 pi k if it cycles around, because they did not restrict the domain in any way in solving this. So you really want to keep your boxes handy, your identities that we've been using all along the way, so you kind of have something to revert back to. So here is some more identities. I hope you're having fun with these trig functions. In these identities, we've already done sum and difference, so now we've got product to sum. So if I'm multiplying sines and cosines together, how could I rewrite that as a new function? So this one says write sine of 2t, sine of 4t as a sum or difference. So I'm going to take it as a product and then have a sum or difference. So if I have sine times sine, I'm going to be using this one right here. So this is my alpha and this is my beta. So that would be equal to 1/2, I'm just using this formula over here, cosine of 2t minus 4t minus cosine of 2t plus 4t. Clean that up. That gives you 1/2 of cosine of negative 2t minus cosine of 6t. And because I, from that previous problem, know that cosine of a negative is equal to the positive, I could just say that's 2t minus cosine of 6t. And I have changed this or written this as a sum or difference. I'm not solving, don't overwork it. Now you can also take it the other way and you can say, what if you had sum to product identities? So it says evaluate, this one actually has some values, cosine of 15 degrees minus cosine of 75 degrees. So for this one, I am subtracting 2 cosines, and so I'm going to be using this identity here. So let's call this one U and this one V, just so we can line them up. So that would be equal to negative 2 sine of, add them together, and divide, times sine of, subtract them, and divide. Let's do our arithmetic. That gives me 2. Sine of 15 and 75 gives me 90 over 2. And 90 over 2, that reduces to 45 degrees. Okay, we know we got something to do with 45 degrees. That's a good angle. 15 minus 75 gives me negative 60 over 2. So let's reduce that. And that's negative 30 degrees. And we know that, working with our negatives from the very first box at the beginning of the lecture, sine of negative 30 is equal to negative sine of 30. That's how those negatives work out. So let's just go ahead and adjust that here. So instead of negative here, it could be out front, or I could throw it into this multiplier. And so now I'm looking at positive 2 sine of 45 sine of 30. If I go to my trig circle, I get 2 sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. So putting that all together, let's see, this 2 will cancel with this 2, so I get square root of 2 over 2 for a final answer. So this one not only put together this new product to sum identity, but we also had to recall from the very beginning those negative angle identities. And so it would be really handy as you work through these exercises if you would have these identities kind of handy so you kind of know what you can use. If you need any help along the way, please reach out and I'll be happy to help you.